For more than 70 years, nuclear fusion has been called the Holy Grail of energy. It's the same process that powers our sun and every star in the universe clean, powerful, and practically limitless. But for decades, it was always just out of reach. Fusion always needed more energy to start than it ever produced. Until now, in a historic scientific breakthrough, researchers finally achieved something once thought impossible: a controlled fusion reaction that produced more energy than was used to trigger it. For the first time ever, humanity crossed the threshold known as fusion ignition, a moment that could redefine the future of energy for our entire planet. This incredible milestone happened at the National Ignition Facility in the United States, where scientists operate one of the most powerful laser systems ever built. Unlike nuclear fission, which splits atoms apart, fusion forces them together. When two hydrogen atoms fuse, they release an enormous amount of energy without creating long-lived radioactive waste or any carbon emissions. But achieving fusion is extraordinarily difficult. Atomic nuclei naturally repel each other, so you have to force them together under truly extreme conditions. We're talking temperatures over 100 million degrees Celsius. That's hotter than the core of the sun. The pressure has to be immense, and the reaction must stay stable long enough to release usable energy. So, how did they do it? The technique is called inertial confinement fusion. Imagine a tiny pellet of hydrogen fuel, smaller than a peppercorn, placed inside a tiny gold chamber. Nearly 200 powerful lasers then blast the chamber from all sides, compressing the fuel with unbelievable force. For just a fraction of a second, the conditions become so intense that fusion happens. In this historic experiment, the fusion reaction released more energy than the lasers delivered to the fuel. This net energy gain is the turning point. It proves that fusion ignition isn't just a theory anymore, it's physically possible. Why does this matter so much? Because fusion offers something no other energy source can. It produces zero greenhouse gases. It can't melt down like a traditional nuclear reactor. The radioactive waste it creates is minimal and short-lived, and its fuel, hydrogen, can be extracted from water. A single kilogram of fusion fuel could theoretically produce as much energy as thousands of tons of coal. This is energy on a planetary scale without the planetary damage. Now, this doesn't mean fusion power plants are opening tomorrow. The experiment required a massive facility and consumed a huge amount of energy overall. The next big challenge is engineering. How do we make fusion reactors smaller, cheaper, and capable of producing continuous power? Scientists are exploring many different paths. Some are using powerful magnetic fields to contain superheated plasma in devices called tokamaks. The famous ITER project in France is one example. But what makes this latest breakthrough so important is that it answers the biggest question that has haunted fusion research for decades. Is net energy gain even possible? And now we know. Yes, it is. Fusion research is accelerating worldwide. Governments are pouring in more funding, and private companies are investing billions. We're seeing new materials, better superconducting magnets, and smarter reactor designs emerge faster than ever. What once seemed perpetually 30 years away is now finally approaching reality. Beyond just making electricity, fusion could power desalination plants to create fresh water, produce clean hydrogen fuel for transportation, and support energy-hungry industries without emissions. It could stabilize global energy supplies and even reduce geopolitical tensions over fossil fuels. There are still hurdles ahead for sure. Scaling the technology will take time, and the infrastructure needs to be built. But the direction is clear. Humanity has taken its first real step toward harnessing the power of the stars right here on Earth. This milestone is more than just a scientific achievement. It's a message of hope. It tells us that a future of clean, abundant energy is no longer a fantasy. It's a future we are actively building right now. Thanks for watching. If you want more deep dives into the scientific breakthroughs shaping our world, make sure to follow and subscribe.